Throughout the course, we've been really focusing on some really hero destruction shots where the damage is really close to camera and we want some really intricate, highly controlled detail on our fractures and the interaction between all of the elements in the shot. And it's important to remember that you could run into lots of different destruction scenarios when working in a proper production environment. And some of those different scenarios would require different workflows and different techniques. And we're constantly figuring out new ways to control things and to achieve the look we're going for. So all the techniques we've covered so far should really give you a solid tool set to handle almost any destruction shot, but I wanted to show you a slightly altered version of the approach that we might use for something like collapsing an entire building. Now I've set up a simple example scene where I've just made a sphere crash into the building. We'll pretend that sphere is, I don't know, a monster robot or airplane or something. And we want this whole building to collapse. So if we were going to have this whole thing shatter, it could be a really painstaking process to, for example, use our Voronoi cutters method to fracture up everything. You could certainly do it, but the Voronoi cutters method tends to leave you with some pretty high resolution fractures. It can be a little bit heavy, and when you need to damage an entire building into lots and lots of pieces, it could be unmanageably heavy to use that Voronoi cutters workflow. I welcome you to try it and maybe change it, and if you find you can use that similar workflow with some alterations, I'd be very interested to see what your approach is. But for this example, I chose to use a pretty basic Voronoi fracture, and I'm basically building just one room and copying that a bunch of times to build this whole building. It could be interesting to have a whole lot more rooms, but I wanted to keep this sim time manageable in this case. Let's take a quick look at how I set up that fracture before we discuss how the simulation approach is slightly different. So I've just created a box here just for one wall, and I've transformed that a bunch of times to make just this cube-shaped room. We could certainly make some nicer room shapes here, but for the sake of an example test, this will suffice. And then once I've made that room out of those walls, I've given it some vertex normals so that things display more nicely. And I've added a connectivity node to ensure that each separate wall gets marked with a different attribute value for the class here. Now the reason I'm using this connectivity information is because when I originally started working on this fracture, I developed some settings that I really like just for one wall. And if I pass this whole piece in to get fractured all at once, then those same settings don't really work as well when used on the entire object. Because I was using, in this case, a static number of points with a certain amount of noise, and I just wanted to reproduce that same look on all of the pieces. So I know in the past we've done for each loops based on a name attribute typically, but if we look at the end node here, you'll see that I'm using the class attribute to loop over all of the pieces. And also it's important to remember that on this connectivity node I've made that class a primitive attribute instead of the default, which is points. And that enables me to just fracture one piece at a time and use the same settings across all of the walls. Now there's a really helpful feature of these for each loops that I don't know if we've discussed before, and that's this single pass option here. This allows you to just run the loop on one of the pieces that you're passing into it. So if you're modifying something in the network in the loop here, you don't necessarily want to wait for the whole thing to cook. It's really helpful to use this to just look at one piece at a time as you're developing it. And then when you're done, just uncheck that single pass option so that it runs on the entire object. Now for the fracture here, I've done a couple things slightly differently than we have in the past. I've started by creating a VDB of the object, and on this VDB, I've turned off the distance VDB, which is the default, and only created the fog VDB. It's very faint here, but it is there. And then I've, as usual, just scattered some points into that VDB. And then I've created a little parallel set of points here to add areas of detail in there. Now this volume BOP creates new density values in that fog volume based on a simple noise. So I'm passing in the position to a turbulent noise node where I've decided on some Perlin noise, and I'm piping that out to density. But I'm also modifying the range a bit because I want this density to be kind of spotty in certain areas. And I'll show you how we can visualize that to dial in these settings to our liking. If we view this density VDB here, it's not very easy to see what's happening. It's pretty faint volume, and it's not super obvious of what that is giving us. So if you use this volume slice node here, this will show you a much more clear representation of the results of this volume. So I'm just going to pin this in the viewport here and go back into that volume BOP. And I'll bypass our fit node here. So this is the default output of that Perlin noise, which is pretty cool. This also, I should add, is a really helpful way of viewing what the different noises will give you to help decide which one is best for whatever you happen to be working on. Now, once we've decided upon the noise type, we can use this volume slice data to get a better idea of what the range is for that noise function. So if you look at the spreadsheet on that volume slice and then sort this density field here, it looks like that Perlin noise is ranging from around 0.6 up through around, let's say 0.3. And we can use that info to tweak the fit function that I'm adding within the BOP here. Now my goal is to change the density values to go from 0 to 1 instead of 0.6 to 0.3. So I started with a source minimum of that 0.6, source max of 1.3, getting remapped to 0 to 1. And let's see what that looks like. So this is what that 0 to 1 remapping will give us. And then I gradually increased this source minimum so that the density values were 0 except for everywhere that the noise value is the highest. So in this case, I just wanted a few hot spots in the noise there and for everything else to be 0, because we just want to use that to really just create a couple small areas of detail in the fracture. In my case, I found that a source min value of 1.05 worked pretty well to just create some nice hotspots where we'll be scattering some points. Now once we have this modified density, then we can scatter some points in there and we can merge those points together. So you see we've got some more sparse areas and some more detailed areas. And then we can pipe that into our fracture here. So if we go down to where I'm exploding out that geometry, you can see we've got some sparser pieces and some more detailed spots. Now when doing looped fractures like this, it's really important to change the name prefix on the pieces, because if you don't, then you'll have multiple pieces with the same name, and that'll really mess things up. So to make sure those piece names are all unique, and the prefix here, I'm just querying the current iteration number of the loop, and then I'm adding that into the prefix. And that'll make sure that all of the names are unique. Now once we've fractured up all of the walls of this one room, we can pack that geometry and use it to build the entire building. I'm starting by just building the ground floor by using a couple different copy nodes here. I'm rotating that room as well, and then I'm merging those together to make that ground floor. And then I'm just moving it to the origin and then using another copy node to build a couple more floors above it. And finally, I'm adding a new name attribute on all of the different pieces so that on this entire building there are no duplicate names between all of the fractured chunks. And then I'm just caching it to disk and then adding a null node for us to reference in our sim.